Okay. Now, I need something from you guys on the other end, like a thumbs up to tell me that you guys can hear me, because I'm testing out in the classroom today. So it's just a new environment. So I'll take a thumbs up. I'll take, oh, okay, Letitia, thank you. Okay, awesome. Okay, great. So let's get started. Are there any questions about 6.3? Okay, thanks, Jared. 6.3, which was on simplifying complex numbers. So fractions inside of fractions. Did you guys wind up hitting anything that was more complex than we talked about in the lecture? I'll wait. I've got time. Okay, cool. So let's go on to 6.4. I really do think 6.4 is the easiest section. It's on solving, and what we're going to do is you kind of learn this trick at the beginning, and then it makes all the fractions go away, and then we'll just spend the rest of the day kind of reviewing for the test, which I believe, yeah, I think it's going to open actually in the middle of the day, in the middle of the lecture. I tried to open it up earlier today, so that way when we got done with lecture, it would be there. Okay, so solving a fraction. So the difference in this section than any section before is we're going to have equations, right? Every section before the 6.1, 6.3 that we've gone over has all been just expressions, right? There has been an equal sign. So this one's going to have a variable. I think your book sticks to x. So we're going to be solving for x. Now, before we get there, we have to talk about, I'm going to use the same wording your book uses, and every book uses a different set of wording. I'll call it the restrictions. Yeah, restrictions. Now, a restriction comes from dividing a fraction by 0. So let me give you an example. We're not going to solve this next one because it's a little more complex than just to start with, but we're going to talk about finding the restrictions. So if I gave you, let's say, 2 over x minus 5 plus 3x over, actually, yeah, that's fine. 3 over x minus 2 equals, let's say, 4 over x. And we're not going to get here right now. This is actually a pretty tough one. But for finding the restrictions, it's not a big deal. Okay, so for finding restrictions, it's really where the denominator winds up being 0. So to find the restrictions, so part A, we're going to find restrictions. Okay, all we have to do is set denominators equal to 0. Okay, that's it. And then we solve it. I guess there's 2 steps there. So the denominator is equal to 0 and then solve. So this first denominator is x minus 5. So we're going to set that equal to 0. And we're going to add the 5. Right? And we get x equals 5. Okay? Then the second denominator is x minus 2 equals 0. Add the 2. And we get x equals 2. And then the last denominator is just x. Well, x is kind of nice because it's just x equals 0. So we've found our 3 restrictions for this equation. X equals 5, x equals 2, and x equals 0. So if I ask you that question, find the restrictions, that's my solutions. Now look, here's the thing. X cannot be these numbers. If we wind up solving this all out, okay, and we wind up with an answer of 5, 2, or 0, we have to just kick it out, okay? And I'll do an example like that. I believe one happens after a few, but I'm going to start with easier equations first. You'll see what I'm talking about. But this is just a good example. So before you get to working on these examples, or on these equations, if there's an x in the denominator, we need to state the restrictions right off the bat. Because if one of those restrictions winds up being a solution, we have to kick it out. Okay, it just can't be a solution. And we'll get to an example, not at first, but I'll get to examples here in a minute like that. But I'm going to be talking about restrictions throughout this lecture because this turns out to be a college algebra topic, a big college algebra topic, actually. College algebra, okay? So this turns out to be a big college algebra topic. So we need to know, we need to have it kind of in our tool bag moving forward. Okay, so then now let's get to actually solving these things. let me steal a really kind of basic one and show you the trick we're going to use. So this is x over 2 plus x over 6 equals 2/3. Okay, you can see that fine, right? Okay. So now to do this, what you're going to do is a lot like the complex fraction from yesterday. We're going to find the least common denominator from all the denominators. Now notice there's no x values in these denominators, so that's why I'm starting kind of easier. But if I look at the 2, and I look at the 6, and I look at the 3, with the numbers it's a little easier, right? For the least common denominator, you're looking for the number that divides into all 3 of these. Well, 6 divides into all 3 of these, right? 6 is divisible by 2, it's divisible by 6, and it's divisible by 3. So my least common denominator is 6. And just like yesterday, you're going to multiply all the numerators by 6, okay? So I'm going to multiply all these numerators by 6. Okay, so really this is very similar to yesterday's, and it's why when we simplify complex fractions, there's 2 ways to do it. It's why I choose the way I did, because it leads you into today's way of really making these fractions a lot easier. So let's see what we've done. As long as you multiply 6 to everything, you're fine. You haven't violated any math rules. So we've got 6x over 2 plus 6x over 6 equals 12 over 3, right? Not crazy. And then what's going to happen is if you do this properly, those fractions will divide away. So 6 divided by 2 becomes 3x, right? 6 divided by 6 goes away, leaves you with the x. And then 12 divided by 3 gives me 4. So in one step, really, I've created an equation without fractions, which usually makes students stand up and cheer. Okay, so let's solve this out now. 3x plus 4x, or 3x plus x is just 4x. Then divide by 4, and we wind up with x equals 1. Okay, x equals 1. And we didn't have any restrictions because these are just numbers. 2, 6, and 3 are just numbers. So x equals 1. And what's the best part about equations is that you can check them. Okay, that calculator that I told you to buy you can put fractions inside of it. But this is really easy to check. So over here, I'm just going to check this one. I'm not going to do this to all of them, but this one's kind of easy to check. So I want to check, is x equal to 1? So let's see. If we plugged it in over here, remember the original didn't have the 6's, right? So 1/2 plus 1/6. Then I want to know, is that 2/3? Well, I've got to get a common denominator at 6. So I'm going to multiply by 3 on top and bottom. So I get 3/6 plus 1/6 equals 2/3. And then now I can add them together. So I get 4/6, and 4/6 is equal to 2/3. That's how it simplifies. So that tells me that x does equal 1. So that was kind of the tough part on 6.1 and 6.3 too. You can't really check your answer. It's not like you're getting a solution. You're just simplifying a really complex expression. So one thing that is nice in 6.4 is once you come to an answer, you can check it by plugging it in. Okay, that really makes it nice. You shouldn't miss one of these questions on the test because of that. Okay, any questions? Or we keep rocking and rolling. Sweet. Okay, so let's do one now with x variables. I'm gonna steal one from the book. Let's see here. Oh yeah, I'm straight up stealing. Actually, I'll steal not the practice question, but or the example. There's a practice question next to it in my book. We've got 5 over x minus 3x plus 6 over 2x equals 7/2. Now I'm kind of spacing these out again because I know I'm going to be multiplying stuff to them. Now this has an x's in the denominator. So even though the question might not ask you to do it, you need to think, hey, what's the restrictions here? If I solve this thing completely down, what's an answer that I just can't have? And now look, I'm going to do actually, I don't have to worry about a constant denominator. 2 will never be 0, right? 2 is 2. But these are variables, so they could be 0. So the first denominator is just x equals 0. I've got to remember that. Now 2x equals 0 is going to be x equals 0 as well, okay? So it kind of doubles up there. So my restrictions are just x equals 0, okay? I cannot have a solution to this equation that's 0, because think about this. If I plug 0 in, like we did on that last example, like to check it, right? If I have plugged 1 in, if I plug 0 into here, this equation, anything divided by 0 is undefined, right? So it's not gonna settle that equation up because you're gonna get undefined numbers. Okay, so just keep that in the back of your mind. I don't think it'll pop up in this example, but it needs to be a habit we start with. So we've got to now come up with the LCD. Okay, now look, I've got an x in these two, so I know I'm going to need an x. I've got a 2 in these two, so I know I'm going to need a 2. Okay, so 2x is going to be my least common denominator. Okay, ooh, you know what I forgot to do? Put parentheses around that. Okay, so I'm going to multiply 2x by everything. 2x here, 2x here, and 2x there. Okay, I say everything, all the numerators. I'm going to multiply 2x by all the numerators. Okay, so when I do that, this first fraction, now we're actually solving. I should put that solving. This first fraction turns into 10x over x, right? 5 times 2 is 10. Now, the second one, I'm going to leave in factored form. I'm going to write the 2x out front because that's how we typically write these. The binomials and trinomials come second. Over 2x. I can see that's going to cancel right there. Equals 14x over 2. Okay? And then I'm going to go to slashing, right? If this doesn't look like a really crappy 80 horrors movie that just has everything slashed out from the denominator, then you're not doing it correctly, okay? So I'm going to slash out the x's there. This entire 2x goes away, right? And now this 2 and this 14, that leaves me with 7, right? 14 divided by 2 is 7. So I wind up with 10 minus, I got that parentheses, be careful, that negative's got to distribute into that parentheses, equals 7. So I've got 10 from the first fraction minus 3x plus 6 equals a 7. Okay, now everything after this is basic algebra. Do you guys have any questions? Any questions moving forward? Is it making sense? Am I the greatest algebra teacher in the entire world? I'll take that silence as a yes. Okay, great. So let's distribute the negative in. So I get 10 minus 3x minus 6 equals 7. And then I just have to solve it out, right? So let's see here. 10 minus 6, that's going to be 4. Subtract the 4. I wind up with negative 3x equals 3. Now, write that over here. Negative 3x equals 3. Divide by negative 3, and I wind up with negative 1, right? Wind up with negative 1. Let's see if it's bleeding over a little bit. So I wind up with negative 1. Now, look, I'm going to check this now by going back to these restrictions. Look, my restriction was 0. So it's okay that negative 1 is a solution, okay? If we would have done all this math and wound up with 0 here, we'd have to kick it out, okay? And we'd say that there was no solution. Now I'm going to take this negative 1, and I am going to check this. This will probably be the last one I check. I'm going to be lazy on the ones here on out, okay? But let's check this one, negative 1. So we get 5 divided by negative 1 minus 3 times negative 1 plus 6 over 2 times negative 1. And I want to know, is that equal to 7/2? So I'm going to focus on that left-hand side, right? Now, 5 divided by negative 1 is just negative 5. Up top, we got a minus. Be careful. The minus on the outside. This would be negative 3 plus 6. So that's a positive 3 in the numerator and a negative 2 in the denominator, right? Is this equal to 7/2? So then, this doesn't look like it's going to equal 7/2 at all. Let's see. So this becomes addition. So negative 5 plus 3 halves. That doesn't equal 7 halves. This is like 15. Negative, I'm sorry. Oh, no, yeah, it does. Negative 5 is negative 10 halves, right? Plus 3 halves. But that's a positive. I got negative 7 halves. That doesn't equal 7 halves. Let's see if I did some goofy math. I might have done something wrong. It happens. Shit, it's hot. Okay, let's see here. Let's see if I goofed up on checking it. That'll be negative 2. That's 3. Oh, you know what? No, that's right. Negative 3 plus 6, that's 3. That becomes addition. This is negative 10 halves, right? Because we have to match it. Negative 7 halves. Maybe I made a goofy mistake then. Oh, you know what? Nope. Negative. Minus 4 would be 3. Oh, man. Huh. That is interesting. It doesn't check out at all. Negative, that's minus. Made it a positive. Huh. Well, this never happens, guys. I'm perplexed. You know what? I'm going to work it again and see if this is going to bother me. This is a me thing. It's 5x over x. And I'm going to do this one kind of quicker because I've already gone through it just to see if I goofed up somewhere or where I goofed up, right? I had to mess up somewhere because negative 7 halves does not equal 7 halves. So again, I'm going to multiply by 2x on everything, right? This becomes 10x over x minus. Now, look, these cancel. I'm going to just do that right off the bat. 3x plus 6 equals, now this 2 and this 2 cancels. Oh, there it is. Bingo, bango. Look what I forgot up here. I forgot that x. It just disappeared. Look. You see that? Crap. Okay, well, that's fine. So I'm going to finish this one out like this. So we get 7x, not 7. So these cancel. So it's 10 minus 3x plus 6 equals 7x, not 7. Ugh. It happens. So distribute the negative, and I got 10 minus 3x minus 6 equals 7x. So now I'm going to just move the x over then, so it can be with his compadre there. And then we get 10 minus 6, which is 4, equals 10x. Oh, this is not going to be as much fun to check because the solution winds up being 2/5. Hopefully, I am not confident at all here. I'm sorry about not having that in the paper there. I'm not confident at all on this one, but I'm going to check it the same, okay? So now I'm going to check 2/5. And if we go back, it's 5 divided by x. So it's 5 divided by 2/5 minus, oh, Lord, this is going to be not fun to check. 2 divided by 2, or 3 times 2/5 plus 6 over 2 times 2/5. And I want to know, is that equal to 7 halves? Now, 5 divided by 2/5. Whew, okay, so if we think of this as we did yesterday, we got 2 complex fractions going on here, right? This would be 5 over 1 divided by 2 over 5 minus, now if you multiply an integer into a fraction, you just multiply at the top. So 2 over 5 plus, now I'm going to think of this as 6 over 1 all over 4 over 5. Look, an integer into a fraction, you just multiply the tops. Okay, 3 times 2, 4 times, and I got to see, is this equal to 7 halves? Now, on this fraction, look, we've got 2 complex fractions, right? On this complex fraction, on the left here, I'm going to multiply, the least common denominator is 5. So I'm going to multiply by 5 on top and bottom. And that would leave me with 5 times 5 is 25. over, now these 5s cancel, 2, right? Minus, now look, same thing, the least common denominator on all 3 of these is also 5. So I'm going to multiply by 5 on all of them. And look, these cancel. So that leaves me with 6 plus 30 over, these cancel, 4. Okay. Now look, you got a calculator. You can pop all this in a calculator and just check it. Okay. This is me without it. Actually, I think my phone's got a calculator, but that's fine. 36 fourths is equal to 7 halves. This would be 25 over 2. Now, I want this to be in half, right? So this would be 18 over 2, which equals 7 halves. Yay! Yes, the crowd goes wild. He does it. He figured out his mistake. Okay. Look, that's part of it. That's part of math. Part of math is when you get the wrong answer, you don't give up. I knew this was wrong. Just looking back, I like check this all correctly, right? If you would have popped this in the calculator, this left-hand side would have popped out negative 7 halves. And you should have gone, oh, wait, that's not right. It should be positive. And so then you just kind of go through and try to figure this out. This is part of the reason we teach math in the curriculum. It's being a little meticulous and developing those problem-solving skills, okay? And no one's perfect, right? Okay, so let's go on to another one. Now that you've seen really 2 of those examples, right? I want you to try one, and I'm going to steal it from the homework, actually. This is number, like any of those. It's kind of like, yeah, let's do number 6. This is number 6 in the homework. It's on page 467. 5 over 3x. Now it says plus 1, but I want you to think of it as 1 over 1 equals 7 sixths. Excuse me. So I want you to try this one. Remember, check 3x equals can't equal 0 really, so x can't be 0. But then multiply every numerator by the least common denominator, and then solve it out. Okay, I'm going to start this, but I want you guys to keep working if you're working. First, we got to have the LCD. Well, we got a 3x, a 1. 1s don't really matter, and a 6. So I know with the numbers, 6 is going to divide out 6 and 3, right? And then I need an x because this first fraction has an x. So I'm going to multiply everything. Say everything again, I mean every numerator by 6x. Okay. And when I do that, I wind up with 30x over 3x plus 6x over 1, right? Equals 42x over 6. Okay. And this will divide out, right? 30 divided by 3 is 10. X divided by x goes away, plus 6x. 42 divided by 6 is 7. Don't forget the x on the 7. Okay. And then we just solve it out. So subtract 6x from the 7, and we wind up with 10 equals x, right? 7x divided, minus 6x is 10. Now I'm going to check it. I know 10's fine because look, if I plug 10 in here, it's 30. So I know that solution's okay to have. I don't know if it's the right solution, but I know it's okay to have that solution. So let's see if that's the right solution. So I'm going to check it. These aren't bad to check. You'll see one here in a minute that's just going to be horrendous to check. Actually, that last one was pretty bad when you have fractions instead of fractions. We get 5 over 3 times 10 plus 1 over 1. We want to know, is it equal to 7/6, right? So we get 5 over 30 plus 1 over 1. Now, look, I'm just going to be lazy and say that to match denominators, I'm going to say that's 30 over 30. I know you're sitting there behind the screen going, why don't you simplify that to 5/6? And yeah, it's, or 1/6. So this winds up being, this side winds up being 35 over 30. And I believe that is 7/6 because when you divide by 5 on top and bottom, you get 7/6. So that checks out. Okay. And again, you can pop that in the calculator and you'll see it. It checks out. Okay. Questions, comments. I know. Nice. Nice. Okay. Any questions? Okay, let's kick it up a little bit. Just like with the complex fractions, the next level are going to be binomials. What if we have more than one term in the denominator and how to deal with it? We're going to deal with it the exact same way as a complex fraction. So if we look at a very basic one, this is number, I'll make one. Well, no, this is actually number 9 in your homework. But I like this example. Okay, x plus 5 over x plus 3 equals 2 over x plus 3. So parentheses around me, right? Because that's what I like to do. I really don't have to do it over the 2. That's just I don't know why I did that. But the other ones I need parentheses around. Now, and this one has a really easy least common denominator because there's only one denominator, right? So the LCD is going to be x plus 3. So now I'm going to write this on the next line because I'm all bunched up here. But I'm going to multiply the x plus 3 to both of these numerators. Ooh, yeah, that's fine. Doesn't matter what order it's in, remember? X plus 3 equals x plus 3. Well, we usually write the 2 out front, don't we? Okay. Makes sense. So I multiplied the least common denominator on both sides. And what happens is they cancel, right? They cancel because it's the only thing in the denominator. So you wind up with x plus 5 equals 2. Okay? X plus 5 equals 2. Subtract the 3, or subtract the 5. And you wind up with x equals negative 3. Okay? So it's not bad. I mean, this one's really easy. And the reason it's really easy is because when we started, the denominators were the exact same. Okay? But I'm going to check it again because it's so easy. So negative 3 plus 5 over negative 3 plus 3, is that equal to 2 over negative 3 plus 3? So we wind up with 2 over, oh no. 2 over, oh no. Oh no. Oh no. We can't divide by 0, right? I know you're saying, but 2 over 0 equals 2 over 0. It doesn't in math, okay? When you see this 2 over 0, what's happened is like super static-y stuff. These can't really equal each other anymore. We don't know how to deal with it in mathematics, okay? We just don't. It's one of the glitches in math. I think we kind of talked about that yesterday or the day before. It's one of the glitches in math. We don't know. This does not equal each other, even though they look the same, because there's a division of 0. Look, if we go back to our original equation, if we would have looked for the restrictions, we would have seen that x equals negative 3 is a restriction. Do you see that? And look, we wound up solving for this and we got the restriction. That's not good, okay? And when we checked it, it kind of in a weird way it checked out, but it's not, we can't have 0 and 0 or division of 0 on both sides. Now we could have 0 equals 0, that's fine, but not divided by 0. So guess what? This has to go away. Actually, even though we did everything perfectly correct, guys, we didn't do anything wrong, this solution would be no solution. So it's that circle with the line through it. Have we gone over that before? Okay, good. Yeah, I thought so. This means no solution, okay? No, oh yeah, we went over it with solving systems of equations that popped up. Yeah, so that it's a no solution. There's just no x value we could put in to make these equal to each other. That's what that means. Okay. Excuse me. That's what that means. Any questions? That's why I chose that one. The even one right after it isn't like that. Okay, so now let's kick it up even further. Just hold on, sit tight. This is, yeah, it's about to be a bumpy ride. Okay, this is number, let's do number 14. Okay, we'll choose another even one. That way you can know the answer. X plus 3, 6 over x plus 3 equals 4 over x minus 3. Okay, 6 over x plus 3 equals 4 over x minus 3. Now, before I get started, I'm going to put parentheses around the numerator or around those denominators. Okay, and then I'm going to think, oh man, this stinks. Like if these were the same, it would be kind of easy, right? Our LCD would just be, you know, x plus 3 or x minus 3. If I do the trick, which rotates this, it doesn't change the sign, right? So that it's not going to make a positive or two positives. So we just have two distinct denominators, like 7 and 2. You know, they're just distinctly different. So if I wanted to find the LCD, I actually just have to multiply them together. But when I do that, I'm going to leave them in this factored form, okay? Just like we did with the complex fractions, I'm going to leave it in this factored form. And I've got to multiply this on both these numerators. So I'm going to try to write it a little smaller. So x plus 3. Now this is a larger marker. X minus 3, x plus 3, x minus 3. Okay. So it looks weirder because we've got binomials, but it's not that bad. The steps aren't bad. And again, what's nice about these, just like complex, we can just cancel a big chunk of it now. That x plus 3 is going to cancel with that x plus 3. That x minus 3 is going to cancel with that x minus 3. So we're left with 6 times x minus 3 equals 4 times x plus 3. And then distribute the 6, distribute the 4, and we wind up with 6. You know, we didn't state the restrictions. We'll worry about that later. So we get 6x minus 18 equals 4x plus 12, right? And then let's move the number over to the right and the variable over to the left. Just do that in one step, okay? So the 18's gone because we added it away, or the negative 18, I should say, we added it away. 6x minus 4x is 2x. These cancel. This leaves me with 30. Oh, we got it right. Divided by 2. And I'll end up with x equals 15. Okay, I'm good. Because, you know, look up here. My restrictions are going to be -3 from here, right? Because -3 plus 3 is 0. And a +3 here. So I know 15 can be an answer. I'm going to check it to make sure it's the right answer. But before I do that, I'm going to pause for a second, take a breath, and ask if you guys have any questions. I know you're probably feeling like I lied to you at the beginning saying that you said this would be a lot easier. Well, look, after this first step, this is easy, right? That's basic solving, right? So once you get past the first step, it does turn into something we've seen, and it should be pretty easy. So do you guys have any questions? Popping up. Hold on. Let's see something. Oh, it's very long. More people. Usually have a lot more people in class. Okay, so let's I'm gonna check it because this isn't too bad to check. If I plug 15 in, it would be 6 over 15 plus 3. I want to know if that's equal to 4 over 15 minus 3, right? So this would be 6 over 18. And I want to know, is that equal to 4 over 12? Well, 6 over 18 is, they're both divisible by 6. That's 1/3. Yeah, 4/12 is 1/3. Hey, they check out. So x equals 15 is my solution. Yay. Again, the crowd goes wild. Okay. Question. Just that good. I can't help it today. Okay, I'm going to keep kicking it up a notch, okay? This is 16. And after 16, I'll probably give you a few where I just want you to work. Because after 16, we've kind of hit all the kind of wilder questions. 16 states, whew, man, okay. 4x squared minus 24x over 3x squared minus x minus 2 plus 3 over 3x plus 2 equals negative 4 over x minus 1. Man, I got to be careful to get this written down correctly. So 4x squared minus 24x over 3x squared minus x minus 2 plus 3 over 3x plus 2 equals negative 4 over x minus 1. Oh, Lord. So I'm going to put parentheses around everything that's a binomial or trinomial for this one. Oh, man. So it's where do you start, right? So if I see this equation, the first thing I'm going to do is I'm going to factor that trinomial, okay? That's the very first thing I'm going to do. I'm going to give you a hint. It's probably going to factor into these two, okay? Because your book isn't that mean. Dr. Martin Gay is not that mean. And she probably made it where these are the other two factors. But let's make sure that's true. It's a good example for factoring. So if I want to factor this, I like that AC method. So I'm going to do 3 times negative 2. That's negative 6. It's got to add up to negative 1. Well, that's going to be negative 3 times 2, right? That adds up to a negative 1. So I'm going to factor this, and then we'll put it back in the fraction, okay? So I'll wind up with 3x squared minus 3x plus 2x minus 2. Parentheses are on the first two and the last two. Notice the addition signs in between. I pull out a 3x and I get x minus 1. Pull out a 2 and I get x minus 1. So I'll wind up, factoring out the x minus 1s. And I'm left with 3x plus 2. Hey, notice these are our two factors. So I'm going to rewrite this now with this trinomial factored. Okay, so I've got 4x squared minus 24x over, let's factor this up. X minus 1 times 3x plus 2 plus, I'm going to do big gaps here because it's looking like that's going to be my LCD, right? So I'm going to say plus 3 over 3x plus 2 equals negative 4 over x minus 1, okay? And notice if I wanted to get an LCD here, this factor, x minus 1 is in 2 of the factors, so I know x minus 1 has to be one of the factors in my LCD, right? 3x plus 2 has to be the other factor. And if I multiply that, let's kind of think ahead. If I multiply this to this numerator, both of them are going to cancel, right? So this denominator will cancel. If I multiply this to the second denominator, the 3x plus 2 cancels, right? And if I multiply this to this last denominator, the x minus 1 cancels. So I know this is going to be my, what's the word I'm going for? My least common denominator. So let's kind of try to put this in so it fits. X minus 1, 3x plus 2, x minus 1, 3x plus 2, okay? And then I'm going to get to slashing. X minus 1, 3x plus 2, 3x plus 2, x minus 1, right? Now there's going to be a lot left over here. This is going to turn into what looks like a harder equation to simplify. So in the first fraction, it leaves me with 4x squared minus 24x, right? The second fraction leaves me with plus 3 times, that's an x minus 1, right? Equals negative 4 times 3x plus 2. Oh, man. That's a lot of work, though. So I'm going to pause it right there before we solve this out. We're going to have to solve by factoring here. Okay? Any questions before I keep rocking and rolling? So let's distribute. We got to use parentheses if we're going to solve. So we get 4x squared minus 24x plus 3x minus 3, right? Equals negative 12x minus 8. And now, guys, it's not just x's and numbers here. We've got an x squared. So my brain automatically thinks, hey, I got to solve this by factoring now. Remember, we're going to factor it, set it equal to 0, and solve, like on the last test. Was that section 5.7 with solving by factoring, right? So remember, to solve by factoring, we have to get 0 on one side of this equation. So I'm going to move the 12x over here, and I'm going to add all 3 of these x terms together. And then I'm going to add 8. Now I'm going to finish. Let's just kind of pull this up. This is a 2-pager. Okay. Let's see. As much page in there as we can. So I started there, so about right there. Okay. So then we wind up with 4x squared. This would be negative 12x plus 3 would be, is that negative 9x, I believe? Yeah, because that would be 15x. And that'd be negative, yeah. So plus 5 equals 0. And notice, so we've got this trinomial, it's squared. Now, we can't do the easy factoring, so I have to do the factoring like we did before. This is a whole new question, right? This is an example of a question from 5.7. Okay, this is a perfect example of a question from 5.7. So I've got to factor this side completely, set each factor equal to 0, and solve. So 5 times 4 is 20. It's got to add up to negative 9. That's going to be a negative 4 and a negative 5, right? So I'm going to split this apart. Down to the next page. 4x squared minus 4x. Now look, I'm going to group those together, plus negative 5x plus 5 equals 0. Factor what, a 4x out, and I'm left with x minus 1. Now notice I need this to be a positive x, so I need to factor a negative out. It'll change both the signs, which I need, and I need that 5 to come out too. So minus 5 over x times x minus 1 equals 0. Factor out the x minus 1s, and I'm left with x minus 1 times 4x minus 5 equals 0. We're almost done. Set each one of those equal to 0. We get x equals 1, add the 5, divide the 4, and we wind up with 5 fourths. Oh, cow. 2 solutions, which is fine. I mean, there's nothing wrong in us getting 2 solutions. Especially, and the reason we got 2 solutions is because this what came from a second degree polynomial, right? Second degree polynomials are going to pop out 2 solutions. We've got to be careful though, because we have to check to see. I'm not going to check these completely. I'm just going to make sure they're not restrictions. Okay. So I'm going to go back here to the very beginning. I'll put my 2 solutions up there. And notice if I plug x equals 1 into this fraction, it would be 1 minus 1. It would be 0, right? So this one, all that work, and it just goes away. Okay. 5 fourths is okay though. 5 fourths is not going to cause either one of these to go to 0 if you want to check it. 5 fourths minus 1 is not 0. And 5 fourths times 3 is like 15 fourths, plus 2 is also not 0, okay? So I know this is the answer because I've got the answer sitting in front of me in the book, and I don't want to check it. It just takes too long. So that is the solution, though. X equals 5/4. Okay, we would just toss out the 1. Question. Now, I think I'm going to backtrack on my statement, this being the easiest section. This is the beginning questions are way easier than 6.1 and 6.3, but it's jumping off the deep end pretty fast. Like this is only number, 16. Okay. Questions before I'm going to pull. So really from here on out, that's going to be really the steps. You're going to factor the denominators completely and then just get the LCD and go forward. Okay. So if we looked at 22, it'll be the same kind of thing. This is 22. We've got 12 over 3x squared plus 12x equals 1. Now I'm going to write it as 1 over 1 because we're doing fractions. Minus 1 over x plus 4. Okay, look, I can't factor the 1 or the x plus 4, but I can factor the 3x squared plus 12x. I can take a 3x out of that, and I'm left with x plus 4 equals 1 over 1 minus 1 over x plus 4. Okay, and I'm going to go even further because the more we can clean up and simplify the fraction, the easier this is going to be in the long run. Okay, and if you notice, this 12 and 3 are going to cancel. And I know you might not have noticed that right off the bat. And in the end, you would get the same answer. Okay, you get the same answer if you work this all the way out and didn't do this, but it's going to make my denominator a lot easier to deal with. So I'm going to write this as 4 over x times x plus 4 equals 1 over 1 minus 1 over x plus 4. So we clean this up a lot, right? We clean this up a lot, actually. So now my LCD, I'll write it over here. My LCD, though, look, I've got a 1 doesn't matter because we always have a factor of 1. But I've got an x plus 4 in both of those. So I know I need x plus 4. And I've got an x here, so I know I need an x. Okay? So I'm going to multiply that to everything. Now I'm going to cancel from this to try to save some paper here. So I'm going to multiply this x times x plus 4 to all of these. I need to get a smaller marker for this part. But notice I'm just multiplying the x times the x plus 4 to all of these numerators. And what happens is we can cancel everything out. Okay? We can cancel everything out. So on the left, we end up with 4. Now this middle term, remember, it was just 1. So we're really left with x times x plus 4. Nothing canceled out for that second term. Minus, now the x plus 4 is canceled, so we're left with a minus 1x. So I'm just going to say minus x. Okay. So this is the new stuff. This is stuff we did in 5.7. You distribute the x, and you're left with x squared plus 4x minus x. Okay. Now look, I've got a squared term. So this, again, just like, I can pull it back up. Just like the last question, I'm left with an equation with a second degree polynomial. I'm going to have to factor this. Now, to solve by factoring, though, I got to get 0 on one side. So let's clean it up. I'm going to cut this up. So this will be 4 equals x squared. I can add these two together, subtract them, I should say. That would be 3x. And subtract the 4 over, and I get 0 equals x squared plus 3x minus 4. Okay, so now it looks like something from section 5.7, right? Now it looks like something from 5.7. You guys see that? Yeah. So now look, it doesn't matter what side. If you're like, man, I have to have variables on the left-hand side and zeros on the other side. If anything's equal to 0, it doesn't matter where you put it, okay? So I'm going to rewrite it up here. Make it x squared plus 3x minus 4 equals 0. And I'm going to factor it. Okay. This is the easy factoring, right? Because x squared is by itself. This would have to be what? Plus 4 minus 1. Multiplies to give me negative 4. Adds to give me a positive 3. Set each one of those equal to 0. Ooh, x equals negative 4. And x equals a positive 1. Right? X equals negative 4. And x equals positive 1. Oh no. But look, negative 4 here. If I plug that into that denominator, I'd have negative 4 plus 4. And that would be a 0 in the denominator. So this actually turns out to be a restriction. Okay, so let's check 1 then. 1, well, 1 plus 4 is 5. That's fine. We've already got a 1 there. It doesn't change anything. Now, if I plugged 1 in here, this would be 3 times 1 plus 12 times 1. So that's 15. That's fine too. So that turns out to be my solution, my lone solution. Okay. Questions, comments, concerns? Making sense? Okay. I'm going to stop there because it'll give us a little time to review. For homework, for homework, for this section, this is 6.4. I would look at 1 through, I can give you that many. It's weird because, in the mixed practice, they get a little easier first. Yeah. I would do 1 through 39 odd. You could keep going. You could go to 47 odd, but if you did 1 through 39 odd and you really kind of understood what was going on, you'll be fine. If you feel like you need more practice, just keep going. Pretty straightforward for homework. Okay. Okay. Questions, comments, concerns. Are you sure we're getting it? Okay. So let's go over. Look, this test is over 6.1, 6.3, and 6.4. And I'm going to tell you what to focus on. So in 6.1, that first lecture was on simplifying fractions, right? 6.1, simplifying fractions. Like if I go to 6.1, like that objective B, which is on page 438, it starts on number 13. Like all of those are good. And if you remember back, we've used this section in every single part moving forward. Today we simplified fractions, right? Once we simplified them, we simplified them. Or once we factored the denominators, we simplified. Or once we multiplied the LCDs, we simplified. So this is the foundation section to all of it. Okay. If you do not know how to simplify, you're not going to understand how to do anything after that. Okay. Like I'm not even going to tell you what numbers are important. Every number I brought up in 6.1 is important with the simplifying fractions. Then we went over multiplying and dividing fractions. Right? I think that was the second day. The first day was just simplifying. The second day was multiplying and dividing. And if you stuck to ones, I'm gonna choose some from here. So this I would do 13 through 32. All of those are important because you need to really have a good grasp on it. But multiplying and dividing fractions, I'm gonna look at like choose some odd ones. 33. Yeah, 35. That'd be fine. And then for the dividing, like 47, 51. I mean, those are good. We're just review questions. If you're going to kind of make a test and make a practice test, I would choose those. And then in 6.3, we went over simplifying complex, right? Simplifying the complex fraction in 6.3. And I would look at really one like number 1 in the homework. Look at 3 as well, one with numbers. And then 15. And then like 31, which is a little more complex, okay? 31. So 1, 3, 15, 31 are kind of a good overview type question. And then today, the solving, I would do all the homework. All the homework I just assigned, because you've got to get that practice down. All the homework I assigned today. Okay, so let me check real fast, because I really do think I put the test in to come up. If you go to tests, yeah, test 4 is in there already. So again, you've got until Sunday at 11:59 to complete it. Same rules as always. Once you start it, you have to finish it. It's multiple choice. You guys have done this for 3 tests now, so we're fine. Okay, that's not that big of a deal. Okay, let me get back to the Zoom meeting. Okay. Oh, hold on, guys. Are there any questions about anything? So I'm going to send out that. I made a questionnaire on, like a survey, kind of like I did at the beginning of class. And I'm going to send it out either today or tomorrow. You'll have it before the weekend. So just fill it out for me. I did ask, like it asks, like what class are you in? What's your name? And then, do you prefer seated or not seated? And then I just asked for a brief description, and it probably won't matter too much for this class. But give me a brief description of why. I'm not judging you. This isn't a judge thing by any means. And this class, it probably won't matter, but the other classes are fairly large, and I have to figure out, I might have to prioritize who comes in and who doesn't, or rotate days. Just know there's a few rules if you come into class. One, you have to wear a mask. You've got to clean your area up. There's like cleaning products in the back of class. You've got to clean it up before you get here and after you get here, or after you leave, or I guess not after you leave, but when you're leaving. Stay away from me, socially distance. And then I think that's the main thing. And also, we might have to rotate. If we have a majority of students that want to be in here, we've got 8 desks. So we might have to rotate who can be in and who can be out. But that's why I'm sending the survey out, is really to figure out if we have to rotate or not. So please fill that out if you want to come to the seated class. I guess if you don't care about coming into class, you don't have to fill it out. But look at it and just go over it, and please be honest with me on it. Okay. Any questions about that? Great. Okay. I will see you all on Monday. Good luck on the test.